Hi, in this video we're going to find the perimeter of a square or rectangle where we're given the coordinates but we don't have a sketch of it. Now we've got this rectangle, let's just draw any old rectangle like this. Yeah, cool, that's a nice one. A rectangle has right angles like this. And these are coordinates for A, B and C, D, which are the vertices of a rectangle. So these might not be in the right sort of kind of position, but it doesn't really matter. But generally, when we label the vertices of a shape, we either go clockwise or anti-clockwise. So I'm going clockwise, A, B, C, D. And let's just put these coordinates on. It's got 1, 3, 5 minus 1, and then 13, 7, and 9, 11. And as I say, I know these are not in the right position because that coordinate should be left that one based on the 9, 11, the 1, 3, but it won't matter in terms of what we need to do to solve this question. Now, to find the perimeter, we need to find this shorter length here, and we need to find this longer length here. And then we can just add those together and duplicate them because we've got 2 of each. Right, how do we find the length of this yellow line here? Now, remember, if we want to find the distance between 2 points like this, the distance between 2 points, what we do is we find the change in the x value. This triangle is the capital letter in the Greek alphabet, capital delta. So that just means the change in x, and we find the change in the y value. And then by Pythagoras theorem, the distance between those 2 points is the change in x squared plus the change in y squared. So we explored this formula in the previous video. So let's just put that in a little box, like this. Brilliant. Now, let's apply it to A and B first. So we've got A is 1, 3, and B is 5 minus 1. So we're going to find the length of the yellow line. So let's use a formula. The distance between these 2 points is the square root of the change in x. So that means the change in the x value from here to here. So if we look at what the x value is changing from here to here, this x value to this x value, we can see it's changing by 4. So it's the change in x squared, so 4 squared, plus the change in y squared. Now we can see the y value is decreasing by 4. So the change in y is minus 4. But to be honest, when you're squaring it, minus 4 squared is the same as 4 squared. So we might as well just think of the change as positive here. So it's going to be plus another 4 squared. And that is going to be the square root of 16 plus 16, which is square root of 32. Let's just simplify that. Our calculator gives you 4 root 2. Okay. So we found this as 4 root 2, or you might have had it as a decimal. And we now want to find the purple length. So that's BC. So let's put B and C. So B is 5 minus 1. And C is 13, 7. And so the distance between them now is the square root in change in x squared. So the change in x from 5 to 13 is 8, so 8 squared, plus the change in the y value squared. So from minus 1 to 7, that's a change in 8, so it's going to be plus another 8 squared. And if we do that on a calculator, that gives you 8 root 2. And you might have it as a decimal, and that's okay. So this is 8 root 2. And so therefore, the total perimeter is the total length around the outside of the rectangle. It's that plus that plus that plus that. So it's 4 root 2 plus 8 root 2 plus, well, this will be another 4 root 2 because that's 4 root 2 plus 4 root 2 plus that's 8 root 2 because it's the same as that. So let's just add those together. The perimeter is 4 root 2 plus 8 root 2 plus 4 root 2 plus 8 root 2. And if you do use on a calculator, we haven't done sort of manipulating surds yet, where surds are when you have square roots of numbers, but your calculator will give you 24 root 2, but I think it wants the answer as a, well, it doesn't say, but let's give the answer as a decimal to 1 decimal place, say, so 24 root 2, and if you do it as a decimal, you get 33.9. There was no units here, so that's units to 1 decimal place. And that is the final answer. That is the perimeter.